In this video I'm going to show you how to solve absolute value inequality. The first step is always to isolate the absolute value. So here we just have to add 5 to both sides. And there we go. We have absolute value of 2x minus 3 less than 1. The next step depends on what type of inequality we have. Here we have inequality that looks like absolute value of something is less than some value. And there we have two ways to solve it. So one way is to translate it to the equivalent compound inequality that looks like this. That's first approach, and the other way is to translate this absolute value inequality into another equivalent inequality, which is compound. So the equivalent compound inequality looks like this. So first let me show you how to do it the first way. We literally just take what's inside of the absolute value and we set it to be less than or equal to 1 or greater or equal to negative 1. And to solve this we just add 3 to both sides and then divide everything by 2. So the answer will be in interval notation written like this. In the second approach, we are going to take the same inequality and we're going to rewrite it as compound inequality. So we're going to take what's inside of the absolute value and set it to be less than or equal to 1. And then we're going to take what's inside of the absolute value and set it to be greater or equal to negative 1. And every compound inequality, and that's what makes it compound inequality, has the connecting word that logically connects the two inequalities. So in this case, the word is and. Now, how do we solve compound inequalities? We solve each inequality individually and then we perform the corresponding operation, corresponding set operation on the two solution sets that we obtain. So let's go ahead and solve the inequality on the left. It is 2x. It's a simple linear inequality, so we just solve it by isolating the x. And the one on the right is also simple linear inequality, which we can solve by isolating it. And now if we look at the solution set of this inequality, it's all the numbers to the left of 2. The solution set of this inequality is all the numbers to the left of, to the right of 1. Now, according to this connecting word, we have to find the intersection of these two solutions. So here's what we do. We draw one of them. We draw another one. And now, just by looking at these two sets, we can easily determine their intersection. So intersection is everything where they overlap. So the answer is also 1, 2. So we solved this inequality in two different ways, and we obtained the same solution both times, which was expected.